Hi, so for this session we'll be looking at the discriminant. And the discriminant is basically an expression that is found in the quadratic formula that we can use to determine what types of solutions we will have before doing any working out. And what we mean by solutions are any x-intercepts, okay? And it's a useful tool to use because sometimes we know with parabolas there may not be any x-intercepts, and so we can use the discriminant to see whether there is a point in actually factorizing or not. So let's just have a look at what we mean by the discriminant. So the discriminant is the part, so this here is our quadratic formula, and this part here is the discriminant, the part under the square root. And with this we can see the types of solutions we will have. And the symbol we use for the discriminant is like a triangle. And so we can say the discriminant, this is the formula for it, b squared minus 4ac. That's all we have to remember. And it comes from the quadratic formula, so it's something that you should already know. And if we have a quadratic equation, we simply have to substitute the values of a, b, and c, just like we do in the quadratic formula. And depending on what our answer is, it actually tells us the types of x-intercepts we will have, or if we have any at all. Now, let's just factorize an example. So if we had to factorize this quadratic equation, we can see it's a trinomial. It's a monic trinomial, which means the coefficient of x squared is 1. So maybe we can factorize this using that easy method. Get our brackets ready. Y already equals 0. We have our x here and our x. It's all positive. And now, is there something times something that gives me 49 that adds to positive 14? That's pretty straightforward. It is 7. Okay? And we know that this here is a perfect square. We can write this equation like this. Okay? And it's a perfect square. If we had to solve this, we can see that our x-intercepts, if we solve this, we'd have x equals negative 7. And also here, x equals negative 7. So it's the same solution. And when we end up with something like this, what actually happens, so we'll look into this more when we start drawing parabolas, but basically when you have two x-intercepts that are the same, and in this case x is equal to negative 7 twice, that's actually telling you that the parabola, so there's x when it's negative 7, the parabola comes down and just touches the x-axis at that one point. Okay, so it's actually intercepting at the x-intercept, just touching it and going back up where it's negative 7. Okay, and that's why it's telling us we have the same thing twice, because it just touches the same point. So now if we wanted to know if we have a parabola that does this, we can use the discriminant. So the first point we'll be looking at is this one here. So if the discriminant is equal to 0, so we'll focus on this first point here. If the discriminant is equal to 0, there is only one rational solution. Sorry, solution, or two equal solutions, which means two equal x-intercepts, okay? And now let's use the discriminant with this example to see if our discriminant equals 0. Alright, so discriminant is equal to b squared minus 4ac. Now, using our equation, okay, what does a equal? A is equal to 1, the coefficient of x squared, b is equal to 14, and c is equal to 49. Now, all we have to do is sub these into the expression here, the discriminant. So we end up with, so b is 14 squared minus 4 times a times c. So minus 4 times 1 times c, which is 49. Now let's just simplify. And 14 squared is 196. And then we have You can put this in brackets if you want to. Minus 4 times the positive 1 times a 49. So 4 times 49 is also 196. And we end up with, I'll just squeeze it down here. I'll change the color so it's more clear. Finally, we end up with the discriminant equals 0. And because this equals 0, it is telling us that our equation, the parabola, will have two x-intercepts that are the same, or just one solution. Okay, so when the discriminant equals 0, we have a parabola that looks like this, where it touches the x-axis at one point and keeps going. Okay, so we say this equation will have one solution, one x-intercept, because the discriminant is equal to 0. Now our second point is, what if the discriminant is less than 0? Okay, so what if we substitute the values in and we get, just say, a -2 or -27, okay? Let's see what that actually will be telling us. So here's our second quadratic equation, okay? Now, for this one, instead of trying to factorize it to find the x-intercepts, I want to determine what types of x-intercepts, if I have any, that I'll have using the discriminant. So we know the discriminant is equal to b squared minus 4ac, and it's the part under the quadratic formula, under the square root. Now, all we're going to do now is substitute. So let's just highlight what a is. The coefficient of x squared is a positive 1, coefficient of b is -2, and the coefficient of c is positive 14. Let's substitute these values in and let's see what we get. So b squared, now please make sure you substitute with brackets, -2 squared, that will become a positive 4, minus 4 times a times c. So 4 times 1 times 14, and we're subtracting that. So we end up with a positive 4, take away 56, and we finally end up with 4 take away 56 will leave us with -52. Okay, now you notice that with this answer, we have a negative value. And because the discriminant equals a negative value, it's telling us there are no solutions. Okay, that's what it's telling us. And no solutions, solutions means no x-intercepts for this parabola. So maybe our parabola, if we draw it, might look like, there's my axes. It could perhaps be going up like this, or perhaps down that way. And if it does that, there will never be any x-intercepts. Now, let's factorize this equation to see if it's possible to factorize. Because it's telling us there are no x-intercepts, so that means it's impossible to factorize it. But let's just make sure. So we're going to try and factorize this. We'll try using the easy method, where we get our brackets ready, and x and x. Now, is there something times something that gives us 14 that can give us, that adds or subtracts to -2? Well, factors of 14, we've got 7 times 2, that won't give us 2. 14 times 1. So you can see it's impossible to do it this way. So maybe if we complete the square, we might have solutions that are irrational numbers, like surds. So let's just have a look. So to factorize, let's try completing the square now. We tried the other way, it didn't work. So to complete the square, we have to halve b and square it. b is equal to -2. So now we're going to halve this by dividing it by 2, and then square it. So we end up with, well, -2 divided by 2 is just -1, and -1 squared is a positive 1. And there it is. And now we have to add this and subtract it to the equation. So we have x squared minus 2x. We know we now put +1 and then take away 1. Don't forget the plus 14 equals 0. If you have forgotten how to complete the square, you have to go back and watch some lessons on that. Now, next step, we know we have to group the first 3 terms, because this here we have created a perfect square. And all we're going to do to factorize this part is to get the brackets ready, put the squared x negative here, so a negative goes here, and then we know the number that goes here is half of a b. Half of a b is just 1. And if we expand this, we get this trinomial. Now here we have minus 1 plus 14. Minus 1 plus 14 leaves us with positive 13, and y is still 0. Now, to keep going, we know the next step here, we've got the squared and the number. We know if it's in the form of a squared minus b squared, we can continue factorizing it. Okay, and a squared minus b squared, we get a plus b in one bracket, and then a minus b in the other bracket. But have a look and see what the problem is. We need to have a takeaway here. What are we stuck with here? We are stuck with a positive. And so because of that, it is impossible to factorize this. If we don't have a negative here, and you notice there is no negative out here either, we're just stuck with this one positive. By observing that, this cannot be factorized, and we're stuck here. And you can see how the discriminant has shown us this, because if the discriminant is equal to a negative value, it's impossible to factorize. And now let's actually try this method, try factorizing this using the quadratic formula, and we'll see what happens. So now let's try factorize that equation using the quadratic formula. I've got the quadratic formula here. I've also circled the discriminant. We have already worked out this part. The discriminant, this part here, b squared minus 4ac, when a is equal to 1, b negative 2, and c 14, gave us a negative 52. So I'm not going to put these values in here because we already worked it out. So we end up with x equals minus b is minus 2 plus or minus, and remember we worked out this part. We got negative 52. So in here it's negative 52 over 2 times a. And 2 times a is just 2 because a is 1. So I'll leave the 2 there. Now, we're going to continue simplifying this. I'll fix that so it's not so far down. Now, 2 negatives here make a positive, so we end up with x equals positive 2 plus or minus the square root of negative 52 over 2. We can see we have a surd, but now I want to point out something with this surd. It's a negative 52. Now, the next thing I want you to do is to put the square root of negative 52 into your calculator and see what happens. And you'll notice that if you try and put it in your calculator, you get this, an error. And that is because it's impossible to have a negative value under a square root. And that means whenever you have this, if you ever try and use a quadratic formula to factorize and you end up with a negative under your square root, you've either made a mistake or you can simply state there are no solutions or cannot be factorized. And that's it. You cannot continue because this gives you an error. It doesn't give you a value. And the reason why it gives you an error, I'll just make some more room, is using our basic knowledge on square roots. And that is the square root of 4, just say, we know there's an invisible 2 out here asking us, is there a number times itself twice to give us 4? Well, we know that 2 times 2 is 4, so the number is 2, okay? And it's a positive 2. And because we're always multiplying a number with itself, so in this case, 2 numbers, 2 times 2, it'll always be a positive answer. And if I had a negative 4 in there, just say, is there a number times itself twice, which we know it has to be 2, to give us a negative 4? But remember, it has to be the exact same number. So if we say, oh, all right, what about negative 2 times, has to be the same number, negative 2. 2 negatives make a positive. So it's impossible to ever get a negative 4. That's why whenever you have a square root and a negative in there, it gives you an error. Okay? It's not the same when we have the cube root of something. For example, the cube root of negative 8. Try and put that in your calculator and see what you get. And you'll notice it gives you a negative 2. And because is it possible for negative 2 times itself 3 times to give you a negative 8? Yes, it is. Okay? Now, the final thing we have to look at when it comes to the discriminant is this one. If the discriminant is greater than 0, So positive, like 1 or positive 2 and so on. If it's greater than 0, that means it's telling us there are two different solutions, two different x-intercepts that our parabola will have. And the second thing we can do, so if you end up with a positive number, when you calculate the discriminant, it's telling you there are two x-intercepts. The next step we can take is this. If the discriminant is a perfect square, so what are perfect squares? Perfect squares are numbers like 4 and 9 and 16 and so on. The solution will be rational, okay? And rational numbers are numbers that can be turned into a fraction. So, for example, you could have 2, you could have a half, or 1.5. Now, if the discriminant is not a perfect square, just say like 8 or 21, you will still have two solutions, but they will be irrational. And we know what we mean by irrational. We have used the quadratic formula before, and when we see irrational numbers, we see surds. And that's where you can leave your answer in exact form or an approximate answer when you round it off using your calculator. Okay? So, to summarize it again, if the discriminant is positive, you will have two solutions. And you can determine if they'll be rational or irrational by the numbers you get. If it's a perfect square, okay, you will have rational solutions. If the number is not a perfect square, you will have irrational solutions. So let's do an example. So here's our third equation. And now let's once again first see if our equation will have any solutions and what type of solutions they'll be, if there are any. So discriminant is equal to b squared minus 4ac. Okay, a is equal to a positive 1, the coefficient of x squared. B is equal to negative 9, and C is equal to negative 10. Okay, let's substitute it into the discriminant. So we've got B, which is negative 9 squared, make sure you use brackets, minus, and then we've got 4 times A, which is 1, times C, which is negative 10. So we have minus 9 squared is positive 81. Okay, and we'll end up with 4, so we end up with minus, and then in the brackets we have 4 times 1, which is 4, and 4 minus 10 gives us minus 40. And then these two negatives will make a positive, so our discriminant will equal 121. Okay, now let's look at this discriminant. Is it positive? Yes. So it's telling us our parabola will have two different x-intercepts, okay, because it's positive. Remember, if the discriminant ever equals 0, it will have how many x-intercepts? It will just have that one where it touches. And we also looked at if the discriminant is negative, so less than 0, it will have no x-intercepts ever, okay? But this one here is positive, so we have two different x-intercepts. And then the next step we can analyze is, look at our number. We have 121. Is 121 a perfect square? Well, if the square root of 121 gives you a whole number, then it is. So get your calculators and put in the square root of 121. And of course, it gives us 11. So it's telling us 121, this is a perfect square because 11 times 11 gives us 121. And because of that, our solutions will be rational. We won't see any surds. So now let's factorize this just to prove what we have found. Now, to factorize this, let's think about the methods we can use. We can try that easy quick method. We can complete the square if you wanted to. You can use a quadratic formula. So always try and use the easy method. If the question specifies, you should know how to use all of them in case it asks you to use a specific one. So for this one, I guess we can use a quadratic formula because we have actually already started that process. But we'll just do the easy method and see if that works. All right, no the coefficient of x squared is 1, so it should be okay. Now, something times something to give us a negative 10 that can get to negative 9. So, what are factors of negative 10? Well, we know that 1 times 10 is 10 and 2 times 5 is 10. But I know that 1 times 10, okay, which gives us 10, it's possible for 1 and 10 to get to a 9. We need to get to a negative 9, and we also need a negative 10. So the 1 or 10 has to be negative. So if we have minus 10 and positive 1, what do we get? We get a minus 9, and there it is. So minus 10 and plus 1. And now equal to 0, y is 0. And now to solve each one, we make each one equal to 0. And then when we solve it, this one will have x is equal to positive 10. And here we will have x is equal to negative 1. And have a look at what we have. Our numbers are rational numbers. There are no surds. We didn't have to complete the square. If we had to complete the square, then we end up with surds. But we got 10 and negative 1. They're rational, and they are our x-intercepts. So x is negative 1, and here, and x is 10. And our parabola will be passing roughly just like this. Okay? And that's what we have found. And using the discriminant, because the discriminant was positive, it told us we will be having two different x-intercepts, so two solutions. And to take a step further, because the discriminant was a perfect square, 121 is a perfect square, it was telling us also that our solutions are rational numbers, not surds. So for our final question, we have to find the solutions for this. But before we do, let's use our discriminant to see what or how many solutions we have, or x-intercepts. So discriminant is b squared minus 4ac. And once again, it's the part under the square root of our quadratic formula. Now, a is equal to positive 1, b is equal to negative 2, and c is equal to negative 14. And let's substitute these values in. So we end up with negative 2 squared minus 4 times a times c times 1 times c, which is negative 14. So minus 2 in brackets squared gives us a positive 4, minus 4 times 1 times 14. So in here we get negative 56. So negative 56. And two negatives make a positive. So we end up with 60. And there's our discriminant. It equals 60. Now let's analyze this. Is it a negative? No. If it was a negative, it's telling us there are no x-intercepts. If it's equal to 0, which it's not, but if it was, it's telling us there is one x-intercept, or two solutions that are the same number. But it's a positive, and because it's positive, it's telling us there are two different solutions. Okay, so two solutions. Not 0, not 1, but two solutions. And now to take a step further, let's analyze our number. Our number is 60. Is 60 a perfect square? Is there something times something to give us 60? No, there isn't. So this is not a perfect square. So not a perfect square. And that is telling us our x-intercepts, if we were to factorize, will be irrational. So we'll end up with surds. So let's now factorize this to see if that's correct. So to factorize this, at this stage we can use whatever method we want. Let's try that easy method. So something times something to give us negative 14 that adds to negative 2. No, it's impossible. So now we can use the quadratic formula. But because the coefficient of x squared is 1, I might just complete the square. I haven't used it in a while again, so I just want to practice. So to complete the square, we have to halve b and square it. So half of b divided by 2 and square it, which equals to 1. So once again, we now add this 1 to our equation. So plus 1 and then minus 1 and then minus 14. This actually looks similar to a previous equation, but there is one difference, and that's this negative here. So don't think it's the same one. All right, get our brackets ready. This here is a perfect square, so we end up with x minus half of b was 1, and then we square it. And minus 1 minus 14 leaves us with minus 15. And now we can see, is it in the form of a squared minus b squared? A squared minus b squared. If we can see that, then we can continue factorizing. And yes, we have a negative here. So yes, it's possible to continue factorizing. But this 15 is not a perfect square. So to square it, we have to square root it and then square it. Okay? And that's, so our a, I'll just rub this bit off. So a is this bit here, x minus 1, and b is the square root of 15. Put it into our formula, so we end up with bracket, a is x minus 1 plus b, and b is the square root of 15. It's in one bracket. In the second bracket, a once again is x minus 1, and this time minus b, which is the square root of 15, and equal to 0. And if we solve each one using the null factor law, we end up with the opposite of what we see. So you can solve it by hand, do it the long way, but I can see if I bring the minus 1 to this side and the positive square root to the other side, x will equal, in this case, 1 and then minus the square root of 15. And for this one, x will equal, opposite of minus 1 is positive 1, opposite of minus 15 is plus the square root of 15. And these are our solutions. You can see they are surds. The square root of 15 is a surd. They are different. They look the same, but one here we're subtracting and over here we're adding. So they're two different solutions. But they're irrational because the square root of 15 is a surd. It's irrational. And you have to use your calculator to get an approximate answer to know where the decimal is. And remember, to begin with, our discriminant was 60, okay? And 60, it was positive, telling us two different solutions. And because 60 was not a perfect square, our solutions are irrational. And we know irrational means they are surds. Okay, so just we'll keep practicing. But remember, this is a useful tool. The discriminant is very useful to help us determine whether we have any solutions, and if we have any solutions, the type of solutions we can get. Thank you.